Have you ever seen a rainbow after a rainstorm? It's like magic, right? These colorful arcs across the sky are one of nature's most beautiful displays. But did you know that there's a scientific explanation behind this breathtaking phenomenon? It's true. Let's dive in and understand how rainbows are formed. Rainbows appear when sunlight interacts with raindrops in a specific way. Think of it like this: sunlight, raindrops, and our eyes work together to create this magical illusion in the sky. It all starts with sunlight. Though sunlight appears white, it's actually a mixture of different colors. This phenomenon is fascinating because it reveals the hidden spectrum within what seems like ordinary light. Remember the colors of the rainbow? Red, orange, yellow, green, blue, indigo, and violet? These colors are not just random, they represent the visible spectrum of light. They are all hidden within sunlight, waiting to be revealed through the right conditions. Don't believe me? Try this simple experiment at home. Shine a flashlight through a prism, and you'll see these colors separate and shine brightly. It's like creating your own personal rainbow. This happens because of a process called refraction. Refraction is the bending of light as it passes through different mediums. When light passes from one medium to another, like from air to a prism, it bends. This bending causes the light to change direction. Different colors of light bend at slightly different angles, causing them to separate. This separation of colors is what creates the beautiful spectrum we see. Now back to the rainbows. Have you ever wondered how these beautiful arcs of color form in the sky? When sunlight enters a raindrop, it acts like a tiny prism, breaking the light into its component colors. The light is refracted or bent, and the different colors within the sunlight separate, creating a spectrum. But that's not all. These separated colors then bounce off the back of the raindrop in a process called reflection, which further enhances the colors. It's like a tiny mirror inside the raindrop, reflecting the light back out. Finally, as the light exits the raindrop, it gets refracted once more, bending the light again. This double refraction intensifies the separation of colors, making them appear even brighter and more vivid. So, what we see as a rainbow is actually the separated sunlight, reflected and refracted by millions of tiny raindrops, each acting like a miniature prism. Rainbows are optical illusions, meaning they don't exist in a specific spot in the sky. They're created by the interaction of sunlight and raindrops, which act like tiny prisms. Their appearance depends on the angle between the sun, the raindrops, and our eyes. This angle is crucial because it determines how the light is refracted, reflected, and dispersed to form the colors we see. That's why you'll never reach the end of a rainbow, no matter how hard you try. As you move, the angle changes, and the rainbow appears to move with you, always staying just out of reach. The most common rainbows we see are called primary rainbows. These are the bright, vivid arcs that appear after a rain shower when the sun starts to shine again. They form at an angle of about 42 degrees from the anti-solar point, which is the point in the sky directly opposite the sun. This specific angle is what gives the primary rainbow its distinct shape and position. Sometimes we can even see a fainter, secondary rainbow above the primary rainbow. This secondary rainbow is usually less vivid and appears at a wider angle. This is formed due to a double reflection inside the raindrops, and its colors are reversed. The light bounces twice inside the raindrop before exiting, creating this unique phenomenon. Rainbows aren't just limited to rain showers. They can appear in any situation where water droplets are suspended in the air and sunlight can pass through them. You can see them in the mist near waterfalls, fountains, or even in your backyard when you water your plants with a hose on a sunny day. The key is the presence of both water droplets and sunlight. Just remember to stand with your back to the sun and look for the magical arc of colors. This positioning allows the sunlight to enter the water droplets at the right angle to create a rainbow. So, next time you see a rainbow, remember the science behind this beautiful phenomenon and appreciate the fascinating way light, water, and our eyes work together to create this natural spectacle. It's a reminder of the incredible interplay of nature's elements.